I don't think I can help with what makes us human, but what I am going to talk about is the next knowledge exponential, which is going to be enabled by open science and assisted by artificial intelligence. I hope that's going to suffice for you. So we live actually in truly exceptional times, and often enough we don't really even appreciate it, how good we actually have it. So I wanted to do with you a little experiment in order to demonstrate this to you. So if you can actually all get up from your seats. Can you please get up? Everybody. Thank you. Are you done? I pre-warned him. He was the first one to stand. Thank you. So now you may sit down again if your birthday falls on an even day of a month. So if your birthday is on the 2nd, on the 4th, 6th, 8th, 10th, 12th, etc. and so forth, until 26, okay, you can sit down again. Remain standing. Yes, thank you. Remain standing if it's an uneven day of the month or 28th, 30th. So about half of you, bit less than that, and it's about right, should remain standing. So what does this mean? Keep on standing, the rest of you. Just 200 years ago, child mortality was 40%. And that means that 4 out of 10 children did not survive their first 5 years of life. Those of you who just sat down, sadly, would have not survived their first 5 years of life. There's some lucky ones still standing, but not for long. We're going to eliminate some of you. Please sit down if you're over 35. All right, now I don't have my pointer, but I'm sitting, okay? Keep on imagining me sitting, like in virtual reality. So, just 100 years ago, the average life expectancy in the world was not more than 35 years of age. It was pretty much like that for the 200,000 years of Homo sapiens existence, both for child mortality as well as for life expectancy. So 100 years ago, I would have not been around to give this lecture, but anyways, most of you would have not been around to listen in any case. Mostly, I think it's the students who are around still, but the mentors are gone, so you figure it out. So we can all sit down, take a deep breath, and appreciate for 1 second that we are actually here in this room. So what has happened? Why are we here today enjoying this privilege to debate what makes us human? Well, it's really all thanks to science, which has saved our lives many times over. The biggest killers in the past used to be infectious diseases and famines. And it was really scientific discoveries in the fields of biology, chemistry, public health, medicine, and as well agriculture who helped to stop them and prevent them as well. So I'm going to show you a couple of these discoveries. These are the 2 graphs overimposed, child mortality, life expectancy made smaller. So let's start. It really started with the basics. 170 years ago, an Austrian doctor called Ignaz Semmelweis showed that childbed fever is contagious, and a simple thing, just as washing your hands, can actually prevent it from spreading. Shortly after, Louis Pasteur developed the germ theory of disease, and then we learned to combat germs and bacteria with antibiotics. Just 100 years ago, the biggest killers were in respiratory diseases such as pneumonia, tuberculosis. Those were really tamed with antibiotics. Who do you know dying of tuberculosis today? The other big killers used to be diarrhea and cholera, and as well, 170 years ago, the first public health scientist, John Snow, discovered that cholera is a waterborne disease. And shortly after, within 70 years or so, by 1920, most Western cities had a modern sewage system installed, so principally just toilets. And we had then in the cities chlorinated water supplies. This in itself saved more than 177 million lives. And something as simple as giving people water when they're dehydrated with diarrhea was only discovered 70 years ago. And it itself saved more than 50 million lives. Blood transfusions. In 1900, Karl Landsteiner discovered blood groups and opened the road to blood transfusions. Shortly after, Levinson discovered that adding citrate allows the storage of blood. These two discoveries by these two people saved more than 1.1 billion, not million, billions of lives. Have you ever heard of those two before? I bet you haven't. They were huge lifesavers. Vaccine is something else that protects us from infectious diseases. It started 200 years ago with the discovery Jenner developed the first smallpox vaccine. And in fact, due to this discovery, smallpox actually became the first human disease to be completely eradicated by 1980. It does not exist anymore. It saved more than 530 million lives. In 1955, Salk developed the first polio vaccine, saving another 120 million lives. And today we have lots of vaccines that protect us against tuberculosis, diphtheria, measles, huge one, and now as well against cervical cancer. Vaccines continue to save lives in the hundreds of millions. The other huge killer in the past used to be famines. People used to starve. But then came the Industrial Revolution in itself, brought about by science in the form of steam engines and electricity, and with that came prosperity. And with prosperity, our world population started to grow. In 1800, at the onset of the Industrial Revolution, there was 1 billion people on the planet. It took 200,000 years to get to 1 billion people. Within 130 years, we doubled to 2 billion, and just within our lifespan, we went to 7 billion people, over 7 billion. And it was really two discoveries that allowed this to happen. In the early 1900s, two German chemists developed a method how to synthesize nitrogen from fertilizer and use it as a fertilizer, mass produce it as well. And the Haber-Bosch process in itself saved more than 2.7 billion lives, lives that were saved from starvation, basically. In the 1940s, Norman Borlaug developed methods how to produce high-yield, disease-resistant wheat and triggered the Green Revolution with that. And it is estimated that another 250 million to 1 billion lives were saved thanks to the Green Revolution in itself. So I think it's becoming clear that science is saving lives. It has allowed us to live longer, healthier, and more prosperous lives than ever before in human history. And here comes the great news. There's more of us, and we are making scientific discoveries at an exponential rate. Today, there is 8 million researchers commanding over a worldwide R&D budget of $2.3 trillion per year. And we spent this money to make more discoveries, produce more research data, and research articles. Last year, the world published around 2.4 million peer-reviewed research articles. And this creates a wonderful innovation and prosperity cycle. Research improves the quality of our lives, it grows our economies, governments, and industries then have more money to reinvest back into research and innovation. But here comes the spoiler, the bad news. This prosperity and innovation cycle is currently severely bottlenecked by our academic publishing system, and I'm going to show you how exactly. Of the 2.4 million science papers that are published per year, most of it, about 90%, are locked away behind very expensive subscription paywalls. So things such as clean energy solutions are just not widely available. The doctor who's treating you today does not have access to the latest medical studies. And in fact, what's worse, not even many researchers try and do that when you're outside of the university, have access to the latest science, because not even the richest universities in the world can afford to pay the subscription fees to all the scientific journals out there. The scale of the problem is actually quite massive. Scientific journals or scholarly journals embargo the access to the recent science for at least 1 year, so you don't have free access to it for at least 1 year, often much longer. And it sums up, counting 2.4 million articles published per year, the accumulated delay to access the latest science is 2.4 million years. And that's just last year. Now, I experienced this firsthand during my PhD. So I'm a neuroscientist. I studied how autistic brains work. And when I published my first paper, I was actually quite excited. I wanted to download it. So I was shocked to actually discover that my university, the Swiss Federal Institute of Technology in Lausanne, which is really one of the highest ranked and richest universities in the world, did not have the subscription to that particular journal. And I realized if I had to download my very own research paper, I couldn't access it, then people or researchers at less well-funded universities wouldn't be able to do so, yet alone families with autism. They'd never read those studies. And that really was a reason why, together with Henry is talking after me, we started Frontiers about 10 years ago, and Idan, our most gracious host as well today, has been there right from the beginning as well, leading the neuroscience journals, and quite to some success, I will show you in a second. Frontiers is an open science platform, and in open science, everybody in the world has the right to access the latest science, whether it's articles or data, for free and immediately. How does it work? Whereas in the closed subscription model, universities pay so we, the researchers, can read the articles. In the open science model, universities pay, but this time to process and publish the science articles, and then everyone can read for free. And it costs much less to process open access articles than subscription articles. So if universities were to switch, they could actually save $6 billion every year to do more research rather than spend it on subscriptions. And because everything is free to access, we could also completely eliminate those quite mind-boggling 2.4 million years of delay. Let's see. And open science actually works, and I'm going to demonstrate this to you on the example of Frontiers. It's become today one of the largest open access publishers in the world. We've pioneered many of the technological innovations that people have become accustomed to in open science, for example, article-level metrics. And as well, the journals work quite well, and you can measure that with citation rates. So you'll find that Frontiers journals, for example, are amongst the top most cited journals in the world. Frontiers publishes the #1 most cited journal in psychology, in neuroscience, so those are Idan's journals, and in plant science as well, #1 most cited, and in many other categories were listed in the journal citation reports as well amongst the citation leaders. You can as well measure that on average citation rates as measured by the impact factor, and you'll find that Frontiers journals consistently rank amongst the top most impactful journals. And as well on the CITE score, which is just another citation metric, this time taking into account average citation rates over 3 years. Frontiers journals are listed in 55 categories, and again, consistently amongst the top most impactful journals. So this works. Open science works pretty well. And here you can actually see, and even more importantly, the uptake of open science in the world. So we've published around 90,000 articles. They've been viewed 420 million times. And as you can see, massively here in Europe and in the US. But I find this quite interesting to see, actually quite amazing. India, look at this. It's hungry for science. Latin America as well. But most strikingly, some of the most downloads actually come from economic hubs. Areas such as the Silicon Valley and Shenzhen in China. And here I'm just zooming in on an article, a gene editing article in the Silicon Valley. And you can see, yes, it's being downloaded in Stanford, but as well in companies in Palo Alto, Los Altos, and in Google. Well, that's because companies today, whether they're small or big, they all depend on science and technology to survive and thrive. Because today's economy is a knowledge economy, and in this context, having this rapid and efficient and free access to the latest science is important not just for innovation, but as well for their growth and economic growth. And today, it's even more important to have efficient access to the latest science. Because we live today in the digital revolution, and that has brought us to a completely new level. And I'm going to elaborate on this for a few minutes. Computers are actually hyper-abundant today, and what's more, straight from the beginning, they've actually been as well connected to each other. So nearly every household in the Western world today has access to the internet, and everywhere else in the world it's growing exponentially. Computers are becoming as well more powerful. This is Moore's law. They have more memory. They're becoming faster as well. All at the same time, the costs are actually sinking. And that is the reason why you find computer processors and chips, not just in your PC today, but nearly in all kinds of devices, from phones to drones to household appliances nowadays. And that, in turn, has led to an explosion, to an exponential growth of data production. So this just shows you the data exchange on the internet alone. Data abundance, more powerful computers, in turn, have led to the rise of artificial intelligence. Now, these are algorithms, networks, we've heard about them today as well, that start to make sense out of the data. And in fact, they are becoming more and more clever the more data becomes available. And the past 5 years have actually seen an amazing rise in artificial intelligence products. You can find them now. Artificial intelligence allows your car, for example, to completely drive by itself, and we're going to have the pioneer from Mobileye, Amon Shashua, talk to us later about this technology. Artificial intelligence as well talks to you nowadays and helps you, for the better or worse, with your tasks. And it beats us at games as well. But, and you can find it really in an abundance now of commercial products. It's growing as well exponentially where you can find these artificial intelligence products. But now let's imagine for a second if we could actually use artificial intelligence and direct it, target it towards science, scientific data, research articles, and help us actually to accelerate the scientific process. Well, what we really need, or what is a prerequisite in all of this in order to allow machines and AI to help us to accelerate, is open science. And we need it in the form of articles and data. Again, for example, in Frontiers, articles are not just free for humans. They're as well free for machines to read and to mine. And in fact, we annotate the research articles in a way that it is very easy for machines to mine them and for artificial intelligence to extract meaning out of them. And we've started just this year to use this type of artificial intelligence as well to assist us in our quality procedures and in our review process. The other prerequisite that you need for AI to help us in science is you need to have access to the data. And the data is now being produced in, as well, exponential growth. I've shown this in a previous graph. It's being produced a lot in labs. But just a tiny, tiny fraction of it is being put systematically into databases or even shared. But when you share scientific data, the benefits are enormous. Let's take as an example the Human Genome Project. At first, people as well tried to patent genes and lock them away behind subscription paywalls, just as we do today and are accustomed to do with our science articles. But then, luckily for all of us humanity, it was decided to make the human genome an open resource. And the benefits of this have been actually huge. It allowed geneticists to develop the first gene therapies for cancer, and for every dollar that was invested into the Human Genome Project, $145 were made in return. It pretty much triggered the entire biotech industry, which today is worth hundreds of billions of dollars every year. Now let's imagine if we could use artificial intelligence together with open science, in combination with open science, to help us address the major challenges that we face today as humanity and accelerate those solutions. So what are these challenges? I'm just gonna name 4. There's the United Nations actually has 17 Sustainable Development Goals, but I think it summarizes, for me at least, in 4 challenges. The first one is we want to eradicate disease, and artificial intelligence and open science could help us in doing so. Today we know that 10,000, or we know the cures to about 10,000 diseases, but 20,000 still do not have a cure. And AI and open science can help us in that. How? For example, and this is just one of the examples, artificial intelligence searches, reads, mines, synthesizes faster than human beings do. It also doesn't overlook. So it can assist researchers in this way in the scientific discovery process. It also can help researchers in the drug discovery by finding new drug targets. For example, IBM's Watson has been doing that for a couple of years and accelerating the drug discovery process in this way. It can help doctors in diagnostics by analyzing medical images and, for example, detecting tumors at an earlier stage. It can help doctors as well in treatments by analyzing the clinical data as it becomes available. And we could even imagine that in the future AI can help us in personalized medicine by starting to make sense out of this multi-omics data. We have physiological data, genetic data, metabolic data, our stress levels, what we eat. And it could help doctors to create these tailor-made treatment plans for individuals. This is the second challenge. We gotta feed all the people on the planet. As I mentioned at the beginning, today there is 7.6 billion people living on the planet, but the United Nations estimates that within the next 50 to 70 years, we're gonna stabilize, and that's really stabilize, not continue skyrocketing, but stabilize at 11 billion people. And we gotta feed everybody. And more than ever, we actually need science and technology to produce more food using less land and resources. Previous scientific advances have given us pesticides and fertilizers. And again, as I showed in the beginning, it's not so bad. It saved close to 4 billion people. So these were great discoveries. But at the same time, they're as well harmful for our environment. So artificial intelligence could actually help us to use less of those, produce more. For example, AI can nowadays scan fields or crops and detect pests earlier, thus minimizing the use of pesticides. In just the same way as AI helps doctors in the drug discovery, it can help plant scientists to produce higher yielding crops, thus using less land and minimizing the use of fertilizers as well. Produce more with less of these substances. The third challenge that we are facing is to provide energy for all the people on the planet and to use our energy actually in a smarter way than we currently do. Today, about 10% of the people use 50% of the world's energy. But tomorrow, many more people will want to use much more energy because as countries move out of poverty into prosperity, people actually want to have light, they want to have fridges, they want to have meat on the table, and ultimately what we want is to have the latest toys and gadgets. So AI can actually help us to use our energy much more efficiently. For example, it's done that already for Google's data centers by reducing the amount of energy necessary to cool the data centers by about 40%. It reduced emissions, it saved money. And what it did for Google, we could imagine it can do as well for cities. Because as more sensors are starting to be connected to the Internet of Things, we could imagine that AI will then help us to regulate the power supplies of entire cities and maybe even countries. So moving from smart cities to smart countries. For me, this, I think, is the most important challenge almost, because we have to achieve all of the above within the boundaries of a healthy planet. Because there's as well a downside to the tremendous improvements in our quality of lives as we live longer, healthier, and more prosperous lives than ever before in human history. We've as well harmed our planet. We're polluting our air. We're polluting our oceans. We're destroying our forests to grow more food. And we've driven other species into mass extinction. And we brought our climate probably to a tipping point from which there might be no return. So the next 50 years actually need to see a complete switch to clean energy and sustainable food production if we want our children, or any other species for that matter, to enter the next century. But I really think it's not about gloom and doom. And why? Because science has really saved our lives and that of our children many times over. And in the future, it will actually continue to do so. But now, more than ever, we need science and technology as well to help us protect our planet and provide this clean energy and sustainable food production for really billions of people. All, but really all, that was achieved up until now, all this tremendous progress, all the lectures that we've seen today, the amazing stuff, the amazing discoveries that have come out, have been achieved despite severely restricted access to our science. Now imagine, we are in the process of making science open, and this is as fundamental and as basic as actually the discovery 170 years ago that simply washing your hands in chlorinated water can save lives, in fact hundreds of millions of lives. So in the future, all of our science will be open, it will be machine readable, and it will be AI ready. This is the mission that we have as well at Frontiers. And that is really when we're going to see and start seeing innovation at a pace that we haven't even seen. If you feel overwhelmed today, tomorrow is going to be even more overwhelming. It's going to be a lot of innovation. It's going to continue to drive our economic growth, and it is going to give us all the solutions that we actually need for this sustainable future. And I think this future is bright because there have never been more scientists on the planet than today. We've never had more resources, and we've never made more discoveries than today. We are today in a much better position to solve any type of problem than ever before in human history. And it's for this reason that science will give us clean energy, sustainable cities, sustainable food production. We will live longer and healthier, and yes, we will also make more money in the process. So I think we can have it all, but we gotta take these simple, fundamental steps first. And that is to make our science open. Thank you. Did I overspeak?
Thank you, Kamila. We have time for a few questions. There's a question up there.
You gave us a lot of numbers about, Kamila, you gave us a lot of numbers about quantity. Do you want to say something about quality? Maybe the fact that we have to pay for things, we are actually paying for the screening process because, you know, when you do imaging or electrophysiology, if you increase the gain and get access to more, you also get more noise.
Yeah, but we're producing more researchers, we're training them at high quality institutions. All the discoveries that we're making today, I think, you know, like are hugely beneficial. Again, you know, like if you go to the beginning of my talk, you know, who wants to die of pneumonia today or of diarrhea or cholera? This is all thanks to the discovery. So today, you know, like these discoveries are giving us vaccines in the, you know, like recent year or so against cervical cancer. We have these gene editing and therapies as well to cure cancer. Who wouldn't want to have that? Excuse me? In all the journals, in all the peer-reviewed, high-quality journals. I'm not sure I understand your question fully.
Okay, I think this one we take then for afterwards. There's a second question here.
Kamila, I think you've given us an extremely rose-tinted glasses view, and of course an extreme anthropocentric one. You talk about people all the time. It's us people. It's we are born, we can live longer, us, us, us. There's lots of other sentient creatures out there. Many of them we've already made extinct. Many more are going to be made extinct over the next 50 years, and all of that at the expense of humanity. So how can we possibly justify that? It can't always just be about us living longer, having access to more toys.
Well, we had that discussion before. So first of all, it's going to stabilize at 11 billion. So we've got to find a solution, right? And the solution is not to send your kids anymore to university or to kill a couple of us off so that other species can live better. In fact, I mean, like, I believe that Yuval will maybe be talking about it, but we see it as well in Steven Pinker's book. There's a wonderful progression. We're becoming more aware, and not just of ourselves, but as well of other species, and it has given rise to you. You don't eat conscious things. I think a lot of other people are becoming as well conscious and turning vegetarian, or finding with scientific methods as well ways of how to grow food in lab reactors or from vegetable ingredients so we don't have to kill them anymore. And people are becoming aware, far more aware of animal rights. 100 years ago, animal rights did not exist. Children's rights did not exist. Today they do exist, and I think more and more people are fighting for that, myself included. I want my kids to live in a world where they do still see maybe a koala bear or an ice bear or any other species that has been driven or is in danger of being driven into mass extinction. Yes, we are living in the 6th mass extinction event, but we're as well in the best of all possible positions and awareness states, I believe, to prevent this and revert this. And it will take us, the scientists, I'm convinced of it.
So what makes us human is that we really can discuss and debate. So I think this is great. But it's in the essence of time, I think we can allow one more question. And Henry, if you could already get started.
Hi. So you mentioned the 17 goals of the United Nations and your favorite goals. But, you know, if I was an alien coming down to Earth and I would look at it, you know, I think we're mostly here scientists. So it's not only about wishful thinking and ideology. It looks like what humanity wants now is being more interconnected, more toys, virtual reality, augmented reality. I think something, you know, if you come at it from an ideological point of view, you can complain. But we are scientists, so I think we want to understand. So I think something additionally interesting is going on here, in addition to solving these big wishful thinking problems. There are other rules at play here that we should be aware of. That's my 2 cents.
Fair enough. Good. I agree with you.
So I think there were more questions. I ask you to sort of approach the speakers in the break after the second talk. So the second talk is given by Henry Markram, and if you see 2 Markrams, I think, in the same session, that was my challenge to keep 2 Markrams in time. So thank you very much, Kamila, for having stayed in time.